Alzheimer's, a brain disorder that causes progressive memory loss and destroys a person's cognitive and physical abilities. It has no cure, which makes it one of the most severe forms of dementia. It manifests symptoms at a later stage, which makes it impossible to treat the deteriorating effect, and the disease finally takes its last turn, and it takes away all your memories and relationships away from you. It steals you from you.
What's your name?
My name is...
Can you tell me how old you are?
I'm 35.
Mum. It's me, Anna.
Anna?
Yes, it's me, Mum.
I'm sorry. I don't think we've met before.
Prolonging Alzheimer's will eventually cause confusion, loss of the ability to speak, communicate, and think. According to the World Health Organization statistics, around 3 million people have died due to Alzheimer's in 2015. The number is expected to triple in 2022. It is also anticipated that 185 million people will be affected by Alzheimer's disease in 2050. So, in the search of how we as a community can better support Alzheimer's patients and their caregivers, research confirms higher chances of being diagnosed with Alzheimer's disease for individuals with mild cognitive impairment only when the symptoms become more apparent. So, it is important for the elderly individuals to be aware of the risks, seek medical consultation, and take necessary precautions at an early onset of Alzheimer's disease to control and prevent their symptoms from aggravating. So, as a solution, we designed a mobile app that will help in predicting the risk of Alzheimer's disease at an early onset. We present to you Nisyaan that will help the elderly individuals in seeking medical attention in time and to reduce their symptoms of Alzheimer's disease.
The aim of the project is as follows: to develop a system which predicts the risk of Alzheimer's disease before its occurrence. The system will recommend the necessary action to be taken and the appropriate medical treatment based on the score. The objectives are as follows. Firstly, to explore the factors from primary and secondary sources contributing to Alzheimer's disease. Secondly, to design and develop a prediction model utilizing machine learning algorithms based on regression analysis. Next, to design and develop a user-friendly mobile application. Next, to integrate the Android application and the model through an API. Finally, to deploy the API and the prediction model onto the cloud. The estimated cost of the project is approximately $1,000. However, due to the availability of all resources, the overall cost is considered to be negligible. The social and industrial impacts are as follows: to receive early treatment and advice from specialists, to create awareness at an earlier stage, to make advancements in medical and health applications. The key deliverables are as follows: to develop a prediction model to detect the risk of Alzheimer's disease using machine learning algorithms, to develop a mobile application, in particular an Android application which acts as the user interface, and finally, to develop a web API to enable the Android app to access the machine learning model using post request.
According to literature survey, 3 similar systems were found. The first system contains a mobile app that is used to predict COVID-19, heart disease, and diabetes. This system uses a diagnostic model that is created using logistic regression algorithm. The second system is a web application that uses a machine learning model to predict the risk of coronary heart disease from patients with diabetes. And lastly, a mobile application that predicts diabetes level using a machine learning model made from a decision tree algorithm. Moving forward, we utilized various tools and frameworks to build our Nisyaan app. The tools and frameworks are divided into software and hardware resources. The software resources are Android Studio, Adobe XD, Jupyter Notebook, Heroku, Jet, GUnicorn, Python programming languages, Java and Kotlin programming languages, and Flask. While the hardware resources are high-functioning Core i7 laptop with 8GB RAM and an Android testing device. Here we have a high-level design of the system. At first, the user provides different inputs to the mobile application. The data is sent to the predictive model using an API. The output is then sent back to the app using the API. At the end, the user is displayed with the output. Not to forget that the API and the model are stored on cloud for maximum efficiency. So, what makes our system different from existing systems? 1. A novel Alzheimer's disease risk predictive model, which is the first of its kind, and second, a uniquely designed mobile application that was built from scratch.
Moving on to the creative aspect of the app has also been translated to Arabic language customized for GCC nationals. The multilingual feature is done using the concept of shared preferences. The first page of the app contains a drop-down menu containing two options, Arabic and English. By default, the language is English. When the user selects Arabic, all the text of the views are changed to Arabic using the text property. The status of the language is stored using the concept of shared preferences. So when the user selects either option in the first page, the status is stored using shared preferences as a variable. The app has been designed to suit elders while balancing the color scheme with the color that represents Alzheimer's disease, which is purple. The text input from the user has been reduced to minimal. For most of the options, icons and text are used for the user to just click and select for their ease of use, which makes this app optimal for elders. The functional requirements of the app are: the mobile app should require users to enter clinical and non-clinical details to predict Alzheimer's disease to determine the risk level. Second, the machine learning model must predict the risk score of developing Alzheimer's disease. Third, the prediction model should be hosted on a cloud environment along with the API. Fourth, the communication channel should be linked between the app and the model through the API. And finally, the app should enable the users to change the language from English to Arabic and vice versa.
For model development, a data mining project methodology called CRISP-DM was used. The methodology has 6 main phases that are business understanding phase, data understanding phase, data preparation phase, modeling phase, evaluation phase, and deployment phase. Furthermore, the dataset used was obtained from Alzheimer's Disease Neuroimaging Initiative, also called as ADNI database. The dataset name is ADNImerge, and it is divided into 5 categories. The categories are cognitive tests, brain features, demographics, proteins and biomarkers, and other unrelated variables. The dataset consists of 49 attributes and 1,241 instances. After data was analyzed through statistical analysis and exploratory data analysis, 7 features were selected as predictive variables. The features are age, education level, race, marital status, functional activity questionnaire, Montreal Cognitive Assessment, and Trial Marking Test Part B. The data sums up to 8 features, including the target variable diagnosis. Next, the model was built using random forest algorithm. This is because random forest utilizes an ensemble learning approach for predictions. It also got the highest recall score compared to other algorithms, and it takes less than 1 second to make predictions. Another evaluation technique used is ROC analysis. ROC analysis is known to be a good evaluation metric as it shows the overall performance of the model. It is observed that random forest has the highest AUC score compared to other models. Hence, random forest model was selected for further processes. This slide shows how the API was developed. Flask was used to build the API by importing the model, creating the required classes and functions, retrieving inputs, and returning the output, and lastly running the API. For mobile development, a front end and a back end were built using Android Studio. The front end takes the features and passes it back to the back end, while the back end returns the output to the front end. For future improvements to our system, blood biomarkers could be added as a new feature to enhance the model. Instead of using Android for mobile development, a cross-platform mobile application could be developed to target a bigger audience. Lastly, developing cognitive tests targeting the GCC locals with the help of medical experts. This would smooth the risk prediction process for the users.
Welcome to the application demo. The name of our application is Nisyaan. The application is developed to detect the risk of developing Alzheimer's disease. This page is the first page which is launched by the application. At the top right corner of the screen, there is a menu where the user can select the language of the application. The application offers two languages, English and Arabic. For instance, if I select Arabic, then all the text is changed to Arabic. And this change is reflected onto the other pages as well. But for the purposes of this demo, I will be selecting English. This is the first introduction page. This is the second introduction page. The introduction pages informs the user about the app and also that the user has to take a few tests to obtain a score. Then is the age disclaimer, where the user's age has to be between 50 and 90 years of age. Then is the privacy disclaimer, which informs the user that the user data is not shared with any third-party member, and also that the user's data is safely and securely stored on the device. Furthermore, the user's data is only stored for a certain period of time for the purposes of calculating the score. Then is the age page, where the user has to enter the age. If, for instance, the user does not enter the age and tries to move to the next page, by clicking on next, there is a message which says please enter your age. Also, if I enter an age which is not in the specified range, then the message will be displayed to the user saying that the age has to be between 50 and 90. So I will enter 60. Then is the education page, where the user has to select the number of years of education that the user has completed. If the user wants to specify a specific number, the user can do so by clicking on the other button and entering the value over here. But I will be selecting masters for this purpose, for the purpose of this video. Then the user has to select the race, and among the options I will be choosing white. Then the user has to select the marital status, and I will be selecting married. Then the next page is the trap score test. In this page, the user has to take the test first and obtain a value. For this, the user has to click on the blue button, and this will download the PDF file for the test, for the trap scores test specifically. Once done, the user will obtain a value, and this value has to be entered over here. Again, if the user does not enter a value and tries to move to the next page, there will be a message saying please enter the score. So I will be entering 60. Similar to the previous page, the FAQ test again has to be solved, first downloaded. So by clicking on the blue button over here, and which will download the PDF file, the user then has to solve this, obtain the score, and input over here. So I will input 2. Then the last test is the mocha test. Over here again, similar to the previous pages, the user has to first take the test, solve the test, obtain a score, and then input the score over here. So I will input 26 and click on submit. Then this is the final page, and the user will be given a value depending on the values for the test scores entered. And for the sample values that I have entered, the risk level is low, and also there is a message displayed over here below the risk level. So this is the final page, and let's say if I want to enter a different set of values to check if the application displays the correct output or not, and for that I will click on the logo at the top over here, and by clicking on the logo, the user will be taken to the first page. So I will scroll to the pages, and I will enter a different sets of values. For example, the age will be the same for now, and again the education level will be the same, masters, and the race will also be same, and the marital status will also be same. But over here for the trap score value, I will enter 100, and for FAQ test score I will enter 7, and finally for the mocha test score I will enter 26. Then once I will click submit, the calculation will be done, and as you can see, depending on the values entered by the user, the risk level will be different, and in this case it is moderate. Finally, when the user is done using the app, has obtained the value and the message, the user can click on the cross button over at the top right corner, and there will be a message which says do you want to exit the application, and upon clicking exit, the application is closed. This will be the demo for the application. Thank you for watching.